This is a recently funded project under Horizon 2020 called Build to Spec, and the idea behind it essentially is we want some kind of formal way using standards to actually assess the quality of what's built as opposed to what was specified. And the idea here is, as Jamie said earlier on, is to try and see whether we can leverage different ICT technologies to support that underlying process. Okay. So very, very quickly, we're all aware of the fact that 40% energy consumption is associated with buildings, and that's translated pretty much to about 36% of the CO2. And as we can see here, the construction and maintenance or upkeep of buildings comprise about 10% of GDP. And what we're trying to really focus on here is in the construction processes. And what we're trying to do is to structure and systemize, if you like, the mechanisms that support decision making, as per the last talk just there as well, and also to realise the fact that the vast majority, and in fact 90% of the workforce in the construction industry has fewer than 10 employees. Okay, so we all know the stock needs to be badly insulated, and we need to make sure that we have a systematic process for performing high energy performance retrofits. So essentially, the timeline associated with this, it began in January of this year and it'll finish in December of 2018. And as I said, it's funded under the Horizon 2020 programme and to a budget of 6 million. And we have a number of partners. I think we have about 20 partners distributed, as you can see, across the European Union, etc. And it was funded under the Energy Efficient Buildings Track 3. Okay. Now, the objectives here is to pretty much radically improve exactly how we can technology enable the self-inspection process. So if you are going to implement certain retrofit type measures, that you have some way of assessing exactly how they perform during the life cycle. So there's some technologies here that you'd all be familiar with that would include thermal imaging, air tightness, indoor air quality and acoustics, but then using kind of technologies that are used in other areas such as drones, 3D imagery techniques and ICT technologies, which we'll talk about later on, including mobile devices and the concept of the Internet of Things. The particular area that we're focused on primarily will be through Jamie's relationship with a company just outside Galway here called Oran Precast, and the idea of prefabricated building walls and systems, etc., whereby you've inserted sensors into them to actually assess the performance post actually deployment in buildings, and we've done this here in 3 different buildings on campus. So at the very centre of this is to ensure that we provide essentially an ICT environment that supports integrated collaborative design and construction management. So if you think of all these jigsaw pieces, that's the main focus of it. So primarily, I won't go into major detail here, but the idea is to actually leverage what we call lean integrated project delivery, integrated project process, and most importantly, integrated design and delivery solutions. So this is kind of the next stage to utilising BIM in a formal fashion, where you integrate in formal standards to do with quality inspection, etc. So the idea here, from our point of view, was to look at how would you take a building. So we've got a building on campus here that's under construction. You see it further down here. It's called the Human Biology Building. It's surrounded by all the BAM boarding, etc. And the idea here is that if there are design specifications, etc., how do you assess post-installation and construction how those specifications have performed? So we might be looking at it from a structural assessment point of view, environmental assessment point of view, but also the thermal energy component of all the different components and systems. So how do you go from a situation like this building, where we've done the same thing, or Jamie in particular and his group has, is that you have a physical demonstrator like this building, and how do you then leverage the use of building information, modelling, building management systems, sensors, features, etc., to figure out exactly how you reduce the gap between the design intent and the actual operation. Okay, it can be structural performance, energy performance, environmental performance, whatever else it might be. So very, very quickly, the work packages were aimed around basically working. If you want to go up to the top there, you look at work package 1, you look at work package 6. So essentially what you're trying to do is to develop an IDDS compliant BIM application. Okay, and that's going to be underpinned by a software platform that exists already, which is a company based in the UK with offices in Dublin called VRM. So expertise then was harnessed from different partners, both industry and academic. So as you can see, working from left to right there, with work package 2, the focus was on thermal self-inspection techniques. So how would you automate the thermal imaging side of things? Working again left to right here, the next one would be indoor air quality, air tightness, acoustic inspection. And the one we focused on primarily in providing a work package was looking at advances in smart materials, so precast concrete forms with sensors embedded in them. both from structural, environmental and thermal performance, and then how you integrate advanced visualization techniques and building information modelling to the actual construction work site. And then, most importantly again, work package 5 is to automate the quality assurance and compliance across all of those different work packages 2, 3 and 4. So each of those, for example, thermal inspection would have certain quality assurance procedures, as would acoustic self-inspection, as would, for example, structural inspection. Then you have other work packages associated with that, which is very important on the left here, which is WP7. So we have real-world demonstrators associated with all of these. So as I said, our human biology building under construction here is a demonstrator for work package 4. Okay. Exploitation and training, communication, dissemination, also very, very important work packages and also essential for all Horizon 2020 proposals. Okay. So this is a bit of an eye test, so I'm not going to get into major detail. Basically, as you can see here, you have all these different work packages that have different timelines, different deliverables, etc. I'm going to focus on work package 4 because primarily that's what we're involved in here. Okay. So as you can see here, in work package 4, we have 6 tasks. Okay, and we lead, as you can see, there are 2 of them. University in Switzerland leads 2, and University in the Netherlands leads 2. Most important thing about here is what's the capability here. Okay, the capability from the university's point of view is work would have been done by Magda. We met earlier on this morning in Zoom, way back in her PhD and her postdoc here as well. She did her postdoc in precast. The idea was to figure out how you could use CFD emerging techniques to help OR and precast look at possible changes to their design, construction, and design, manufacturing, construction of the precast elements. So it's that mix between the actual design, manufacturing, construction, and then scenarios to see whether you could actually improve maybe thermal performance, acoustic performance, structural performance. R2M are an Italian company and they focus primarily on technology transfer within European projects. So they were trying to figure out the best way to take the different technologies out of the improve or disseminate or whatever else might be. The coordinator are based in Biarritz, just south of Biarritz in France. They're called Novatech. And as you can see there in 4.3 we have Visria from the UK and we have TNO from Denmark and ASCAM from Spain, which is a large construction company. So the mix here, basically, and down below in 4.5 we have the Passive House Institute, so I know there's Passive House people here as well. So the idea here is to bring together all the different expertises to do with precast, design, manufacturing, construction. Okay, from Visria's point of view to do with measurement, testing, etc. Building information modeling from TNO, ASCAM from real world construction projects, ourselves from the numerical modeling, etc. And the different tasks you can see here is firstly develop methodology. That's our main responsibility in this project. Okay, as is the smart materials to work directly with OR and precast to figure out exactly how you can smart the materials so that when they're actually in situ they can deliver you performance information, both structural and environmental. We're leveraging the capability of ETH to develop a very advanced thermal imaging technique in a sense, using from a project called the Google Tango project that they've done with Google. So it's basically a kind of a mobile phone, if you like, put a camera on it and basically they're able to take snapshots of the different materials and basically turn them into 3D wireframes, etc. and possibly add more materials to them. So it's for going on site, actually capturing the images and trying to determine whether the construction features are as they were designed. Okay. TNO are the building information modeling people. They have a product called the BIM server developed over the last 15 or 20 years. It's open source and it's free, etc. So the idea is, can we bring back all this information into one database so that we can do the quality inspection on it? And I'm going to show that in a second. The central part then after that is the TNO BIM server will tie in then with the VRM platform. VRM is the platform that's supposed to incorporate this whole idea of an integrated design and delivery solution. Okay. So the way we kind of go about it is, and the kind of pictures here just indicate that we have the standard way of doing ISO 9001, such as the photograph up above, between filing systems and quality checks and various engineering tests, to try and move into smart materials so that we can do the modeling, okay, and the design up front to determine what sensors should go where so that we can extract the data from the built product and perform the quality inspection automatically. Okay, so that involves, as you can see there, 3D modeling, etc. It also involves a lot of design work in the lab, so the hot boxes, etc. And testing, for example, particularly from the structure side, where exactly these sensors should go. So you're talking about thermistors, you're talking about vibrating wire gauge sensors, etc. And we've done an awful lot of work through Jamie's group in particular on this building and on the building north of the campus here, so Life Courses Institute. So that's been brought now into the new building that's been constructed up here. Okay. So again, I'm just emphasising the IDDS. This is the systematic approach on which this VRM technology is going to leverage the idea of lean collaboration throughout the different stages of a project. And as I said, the different technologies that are going to be leveraged here is going to be the ETH and Google Tango technology that allows you basically to take photographs and build up 3D wire images that then can be brought into the building information model. And later on, when you're talking about the actual worksite building analysis, we're looking at, again, thermal imaging and possibly, again, using this technology, but also possibly the use of drones. We're not quite sure whether that's going to happen or not, but at least what we've done at this stage is we've installed a camera sitting on the top of the crane there and taking images, I don't know how often, and every couple of minutes. So it's basically tracked the whole construction of that building over here since its inception. So again, the BIM server, so I'm not sure what BIM tools you're all familiar with, etc., but the BIM server is an open source building information modeling database, and it's been developed by TNO in the Netherlands. And they will essentially offer the link between the data we're sending back both from here or in precast, and also the physical data will come back from the wireless sensors, and they will hook it up then with this tool called Refurbify. This is the VRM technology. Okay. And once that's done, then this information then will be ported essentially to the cloud, and they can then go on site as the construction is happening with tablets, etc., and actually check through either visual inspection or photographic inspection, is what's been constructed actually there? So is it being built to specification? That's the overall view of it right now. And again, just our approach that's been developed over the last 3 or 4 years essentially goes around the idea of leveraging building information models, developing numerical models using computational fluid dynamics, then figuring out different performance indicators to do with maybe heat, sound, moisture, structural, whatever else it might be, and then developing measurement frameworks, as in physical measurement frameworks that allow us then to test the model against the actual physical data. And with that combined with smaller scale demonstrators in the lab, we want to focus on particular key elements to do with the research. And again, our approach is physical demonstrators, as in real buildings. We use the lab to a certain extent, but it's mostly on real case demonstrators. And in order, the building you're sitting in now would have been a starting point for a lot of this research. Following that then, from the experiences of that, the Life Courses Institute that's just occupied the last year or so, and then this new building that's under construction you'll see down here south of the campus. And again, the experience developed here would be to do with the different vibrating wire gauges or thermistors or whatever, and most importantly, understanding the structures themselves, understanding where the sensors should go depending on the structural type, wall, floor, ceilings, etc. These are just quick shots that have been developed over time with our precast. That's the most appropriate locations and sensor types, so the data can be brought back and that data can be analysed and been used to develop CFD models, etc. Okay. Some things here that just come out here from the data. Some particularly here to do with the curing aspect of concrete, so you get hydration, etc. So you can see the peak in the temperatures, etc. But these are ways of analysing the different key performance indicators for the different structural components and systems. This is where we use the CFD modelling for the different innovative wall, floor, ceiling systems, etc. So we determine whether they're performing in terms of an internal environment or in terms of an actual building component or system. And again, this is the lab where we're looking at thermal expansion coefficients, or we're looking for structural tests, or we're looking here for temperature distributions or heat transfer characteristics for different sort of scenarios that, for example, our precast might want to think about without going to full design or manufacturing. And that's pretty much it.